I thank you for joining me in my second of a series of videos on using what I call BSA tables, sometimes called PCA tables, using these tables in order to solve limiting reactant problems. So the chart that we're going to fill out is going to be filled out in moles. So you can use other units for these. Typically we will be using moles, but you can use molarity if all dilutions have been accounted for. You can use pressure if volume temperature is constant, volume of a gas, these would both be gases, if pressure temperature were the same throughout. So it's actually fairly flexible. Now, in this first example, I want to get to moles. I have 48 liters of hydrogen gas. It's at STP. And if you are honors or pre-AP, hopefully you are familiar with the molar volume. If you are AP, I would hope you would forget all about molar volume. Molar volume has caused kids to miss so many points on an AP test. I have seen molar volume used in so many incorrect contexts, especially aqueous. I mean, it's from the ideal gas law, not the ideal aqueous law. And the chances of you being able to use it on an AP test are pretty slim. If you are IB or pre-IB, I want you to know that the molar volume is actually 0.7 liters for every 1 mole of gas. So just a few nuances there, depending on where you're coming from. Okay, I have 15 grams of nitrogen. I'm going to assume that you can do mass to moles using molar mass, and you'll double check my numbers. I got 0.535 moles, and I don't have any of my product ammonia. Now, the key here is to determine which one is limiting. So to do that, we're going to compare what we have available to the ratio, that 3-to-1 ratio that is needed for the reaction. So what I'm going to do is I'm going to take this 2.14 and divide it by 3, what I have over what I need. And when you do this, I get 0.713. This one's a little easier because what I have over what I need is 0.53. 3. 5. Okay? Now, when you've done that, you pick the smallest. It's not always the smallest from this original column. You have to be careful. These relate on a mole-to-mole basis, and so we have to do that little bit of analysis. When you're done with that analysis and we've identified nitrogen as our limiting and hydrogen as our excess, then you can ignore these numbers. Especially at the honors level, they're not important. At the AP, yes, but at the honors, no. So we're going to start with that limiting, and we lose reactant, and we gain product. But we have to consider the mole-to-mole ratio because I lose 3 hydrogens for every 1 nitrogen. So we have to multiply this by the mole ratio. And I want you to notice that the limiting coefficient, that implied 1 in this case, is always in the denominator. That's because our mole ratio is where we're going to on top, so its coefficient is on top, divided by where we're coming from, which is the limiting. So the limiting balancing coefficient goes in the denominator. Once you're at this point, you're in really good shape. That was the hardest part. Now all we have to do is add up all the BS and we get our final answer, and I get 0.535 moles of hydrogen, of course 0 moles of nitrogen. So in my notes there's a couple questions at the bottom, and I have 0 grams, 0 moles of nitrogen, and I have 1.07 moles of ammonia. Now it asked me how many liters of hydrogen I have. Honestly, I think this isn't the best question because I'm trying to physically figure out if you've got a situation where you're keeping the pressure and temperature constant, as moles change, then the volume will change. It would be rather a unique setup though. So I'm going to take that 0.535 moles. I'm going to multiply by 22.4 liters per 1 mole. And bear in mind, AP, the only place you're going to see this is maybe on a multiple choice. So be really cautious about using that handy little conversion factor. So I had 12.0 liters of hydrogen, and then it asked me the theoretical yield of ammonia in liters, assuming STP. So this is assuming we can somehow, siphon off the ammonia separately from the hydrogen. That's why I said took it out of a book somewhere, and I think it's a little, awkward, but we're going to run with it. So I have 1.07 moles times, again, assuming STP, 22.4 liters for every 1 mole. Okay, and so my theoretical yield for the ammonia, that's the maximum I can make, assuming that nothing went wrong, and I don't have that number written down. So I'm going to let you do that value for me, okay? And that's this value right here. I do not have it written down, but that would be our answer, okay? All right, so until my next video, good luck with chemistry.